Beam general. The following figure shows one beam supported by two columns. This beam, due to its flexibility and the loads that it bears, self-weight, supported slab, walls, etc., is deformed by the way mentioned in Chapter 1.4.2. The reinforcement placed inside beams consists of the longitudinal bars and the transverse reinforcement in the form of stirrups, ties. The longitudinal rebars are placed in order to resist the flexural tensile stresses that appear along the beam axis, while stirrups are used to carry the diagonal tensile stresses caused by shear. Moreover, stirrups help in the confinement of longitudinal reinforcement in critical areas. Figure 1. The number placed in front of the beam, B1, indicates the floor that this beam belongs to. In this case, it is number 0, which corresponds to the ground floor. 1 represents the first floor, 2 the second floor, -1 the first basement, and so on. This means that the beam's number prefix is -2, -1, 0, 1, 2. Figure 2. Since most of the times beams with names B1, B2, etc. appear in all floors, it is compulsory to use the prefix both in the constructional drawings and in the beam's labels so as to avoid confusion with the drawings and the various materials used. These are specified in the beam's labels. The label 10S0010/100 means that for the critical length of the beam, which is 1.0 meter, 10 stirrups will be used, with a 10 diameter and 100 millimeter spacing. In the detailed drawing of the following continuous beam, the label 12S08/170 that refers to the beam's span, which has a length equal to 2 meters, indicates that 12 stirrups with 0.8 diameter will be placed around every 170 millimeters. The exact distance between them is 200 over 12, which equals 167 millimeters. Figure 3. The stirrups hold the rebars in place, and they carry the diagonal tensile forces that usually shift direction. The beam's region next to the face of the column is characterized as critical because it carries the largest stresses. Its length is equal from 1 to 1.5 times the depth of the beam. In our example, was assumed as 2 times 0, 50 equals 1.00 meters. The stirrups placed at the critical areas must be narrow, spaced, and properly closed. The required anchorage length for the lower fibers of the beams is 30% smaller in comparison to that required for the upper fibers of the beams. This is the reason that in finishing nodes, the lower beam reinforcement bars are anchored with a smaller hook. Additionally, in order to create more space for the concreting process, the lower reinforcement bars are shorter than the upper bars, as shown in the beam reinforcement details. The beam's width must be greater or equal to 200 millimeters, and at least 2014 must go through the full length of the beam, both at the top as well as at the bottom.